Hello 6th grade, this is video 2. I know it looks a little different. Don't worry, you haven't missed anything. I just had to put both videos separately so that we could get all of it together. So we just finished talking about how when winds blow towards the equator like this, they actually curve as they go down like this. Instead of going straight up or down, they curve. And I said that that was because of something called the Coriolis effect. Now I want to give you a definition for the Coriolis effect first. The Coriolis effect is a phenomenon that causes fluids like air and water to curve as they travel across or above the Earth's surface. So as water and earth travel around the Earth's surface, they actually end up curving like we saw there. Now let's explain this with another diagram. So let's draw our Earth here. Nice Earth. And this is our equator. Now we know that the Earth spins around an imaginary axis like this way. Okay? Now, the Coriolis effect means that this spot here actually ends up spinning much faster than this spot here. Now that happens because the distance between the equator and the axis here is much bigger than the distance here. So even though both of these spots spin all the way around in one day, this spot has to go around much more distance, meaning that it's traveling much faster. Let's see what that does. Airplanes actually are affected by the Coriolis effect, so we're going to use those as an example. If we have an airplane here around the equator that takes off and it travels straight north, it actually doesn't end up going straight north. Because it's traveling so much faster going this way at the equator, it's going to conserve that momentum and end up veering off in that direction. The opposite happens if we take an airplane here and have it go down south. It's actually going to veer this way. Now that explains what we talked about with those winds towards the equator. Alright, but we actually have 3 sets of winds, and I'd like to go ahead and diagram the global winds. But right before that, I want us to remember something very important. Winds are always named by where they come from, not where they are going. So, if a wind is blowing towards the east, it is actually called a westerly wind. I know that that can be kind of confusing, but you will get used to it as long as you remember that key point. So, if we have our Earth here and our equator in the middle, we have a band in between the equator, or 0 degrees latitude, and here, which is 30 degrees latitude, called the tropic zone. Now this is where we get what we call our trade winds. These are going to blow towards the equator and end up veering off to the west like that, like we talked about as they travel down. Now these are called the northeast trade winds. We have the same thing happen on the south with winds going up towards the equator, moving towards the west, and those are then called the southeast trade winds. So go ahead and label that in here. These are called the trade winds. Now, from 30 degrees to 60 degrees latitude, we have what are called the westerlies. Now, what we just learned was that winds are named from where they're coming, not from where they're going. So if winds are named the westerlies, it means that they actually come from the west. So these winds actually move up towards the poles and move east as they're going this way. And they curve in that direction. The same thing happens in the south, except they move down towards the South Pole and curve to the east like this. So again, these are called our westerlies. And up at the top here, above 60 degrees latitude, we have what are called our polar easterlies. These are winds that move towards the west like this. Same thing at the South Pole, they move towards the west like this. Again, those are called the polar easterlies. Okay, now there's one more thing that I want to talk about as far as global winds. These areas here along the 60 degree, 30 degree, and equator lines that we drew here are areas of relatively low or no wind. Most of the wind in the world happens in between them, and these spots end up being very dry and not having much wind. Now, that actually concludes everything that I want to talk about. So come into class with questions. I know that you're not going to completely understand all of this, but I want you to have the graphic organizer filled out and be ready to do some activities regarding these kinds of things. We're going to learn more in class. Thank you so much, and I hope you have a great day.